So I'm going to review the topics from Module 3 before you take your test. So in Section 1, we talked about converting between units. So if Joseph reads 23 pages a day, how many pages does he read in a year? So we currently have 23 pages per day, and we want to convert to pages per year. So what I'm trying to get rid of always goes in the opposite place. And we know there are 365 days in a year. So we do 23 times 365, and we get 8,395 pages per year. Secondly, we have, if you run the 100-meter dash, how many inches have you run? And we know that 1 inch equals 2.54 centimeters. So we currently have 100 meters. My first is to go from get rid of my meters and convert to centimeters. So there are 100 centimeters in 1 meter. And then lastly, I can convert from centimeters to inches. And there are 2.54 centimeters in 1 inch. So we do 100 times 100, and then we divide by 2.54, and we get 3,937.01 inches. Okay. So in Section 2, we were converting multiple units. So we want to convert 2,000 feet per minute to miles per hour. And I give you that there are 5,280 feet in a mile. So 2,000 feet per minute. So I have to do two conversions. I have to convert feet to miles and minutes to hours. So I'm going to start with the feet to miles, since that's one step conversion, since 1 mile contains 5,280 feet. Okay, so now I work on converting minutes to hours, which is also going to be one step because there are 60 minutes in 1 hour. So we're going to do 2,000 times 60, and then we're going to divide by 5,280. And we're going to get 22.72 repeating, so 22.73 miles per hour. So in Section 3, we were solving proportions. And remember, in order to solve a proportion, we cross multiply. So our first proportion, x plus 5 over 4 equals 2x minus 1 over 3. We're going to cross multiply, and we have 3 times x plus 5 equals 4 times 2x minus 1. The most important thing to remember when cross multiplying is to distribute to both terms. So we get 3x plus 15 equals 8x minus 4. Subtract 3x. We get 15 equals 5x minus 4. Add 4 to both sides. We get 19 equals 5x. Divide both sides by 5, and we get x equals 19 over 5. So remember, the only time you're allowed to give me a decimal answer is when you are doing a word problem or converting units. If you are solving an equation, your final answer must either be written as a whole number or as a fraction if the answer contains a decimal. Okay. So our next problem, we're still cross multiplying. So we get 5x equals 5 times 2x minus 6. So we get 5x equals 10x minus 30. Subtract 10x. We get negative 5x equals negative 30. Divide by negative 5, and x equals 6. So in Section 4, we were setting up proportions to solve word problems. So Micah can eat 21 hot dogs in 6 minutes. She wants to know how many minutes it would take her to eat 35 hot dogs if she can keep up the same pace. So So we have 21 hot dogs in 6 minutes. So when I set up my proportion to solve, I have to make sure I keep my units in the same place. So we had minutes over hot dogs. So we want to solve for the time in 35 hot dogs. Okay. Then we cross multiply. So we get 6x equals, and then 21 times 35 is 735. Divide by 6. And we get 122.5 minutes. It is important to remember to include units anytime you solve a word problem. Next we have, in the year 2000, there were 8.7 deaths per 1,000 residents in the United States. If there were 281,421,906 residents in the U.S. during 2000, how many people died that year? So we have 8.7 deaths per 1,000 residents, and we want to know how many deaths there were for 281,421,906 residents. So we cross multiply, we get 1,000x equals, and then we have to do 281,421,906 times 8.7, and we get 244,837,0582. Then we're going to divide by 1,000, and we get 244,837,0.582 deaths. So that's 2,448,370.582 deaths. Anytime you're solving a word problem and you get a decimal answer, you must give me at least one decimal place. You are not going to round up to whole numbers for the word problems. You are going to give me a decimal answer. So next we talked about scale drawings. So we have, if a blueprint drawing uses a scale of 1 inch to 9 feet, what is the actual size of a room that is 10 inches by 12 inches on the blueprint? So we have to solve two proportions here. So we have to take our length and our width and convert them both to feet. So we have 1 inch per 9 feet. So first we have our length, which is 10 inches, and we want to know how many feet that is on the scale. So when we cross multiply, we get x equals 90 feet. Then we have to do it again for our width. So we have 12 over x, 12 over y, because we have to use a different variable. And when we cross multiply, 12 times 9 is 108 feet. Again, it should be y. So our room is 90 feet by 108 feet. So a scale drawing setup is very, very similar to when we set up the application of proportions. It's just that with a scale drawing, the units don't usually match. You're usually using a proportion to use a scale from going smaller to bigger instead of actually keeping from cups, like 1 cup to 2 cups, and for baking, like 1 cup of sugar for every 2 cups of flour. And you want to know, if I only have this much flour, how many cups of sugar do I need? So it's a very, very similar process, but it's not exact. So next, in section 6, we talked about the Pythagorean theorem. So remember, Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of your right triangle and c is always the hypotenuse. So we want to find the hypotenuse of a right triangle with legs of 5 and 9. So it doesn't matter what I plug 5 and 9 in for A and B. So I could put 5 squared plus 9 squared or 9 squared plus 5 squared. but I do have to have the hypotenuse kept as c. So 5 squared is 25, 9 squared is 81. 25 plus 81 is 106. Then we take the square root, and we get 10.3. You are allowed to give me decimals for the Pythagorean theorem when the answer isn't an exact number. So if it's not a perfect square, you can give me a decimal. And again, it always has to be at least one decimal place. And in this case, you get 10.2956. So if I wanted to round 2 decimal places, the 5 would make the 9 become a 0, so I have to do 1 decimal place here. So next, we are given the right triangle, and we want to solve for the value of x. So the hypotenuse is always across from the right angle, so I know 20 is c. And it doesn't matter how I label x and 14. X could be a or it could be b, it doesn't matter. So I'm going to set it up as x squared plus 14 squared equals 20 squared. Could have set it up as 14 squared plus x squared, it doesn't matter. So once we square 14, we get 196, and 20 squared is 400. Subtract 196 from both sides, and we get x squared equals 204. Then take the square root, and we get x equals 14.28. All right, so section 7, we talked about area and perimeter of compound figures. So we had a figure comprised of multiple shapes, and we wanted to find the area and the perimeter. So I'm going to start with the area. It's always best to split it into rectangles, squares, and triangles. So I have a square, a rectangle, and a triangle I need to find the area of. So the area of a square, it's a 4 by 4, so its area is 16 centimeters squared. The area of the rectangle, so its length is 6, the width is 10, so it's 60 centimeters squared. So this was 4 times 4, this was 6 times 10. And the area of the triangle, 1/2 base times height. So we know this little piece is 2, which means the height is 8. So 8 times 6 divided by 2, and we're going to get 24 centimeters squared. So that was 1/2 times 6 times 8. Okay. So my total area of the entire figure, I have to add them all together, 16 plus 60 plus 24, and we get 100 centimeters squared. So 16 plus 60 plus 24. Now I want to make sure for my perimeter I have everything labeled. So 4, 4, 6, 6, 2, 6, 10. So the only thing that's not labeled is this bottom part, which if I look is comprised of this 4 and 6, which means it has a length of 10 centimeters. So my perimeter is just adding them all together. So 4 plus 4 plus 6 plus 6 plus 2 plus 6 plus 10 plus 10. So 4 plus 4 plus 6 plus 6 plus 2 plus 6 plus 10 plus 10 is 48 centimeters. So anytime you're finding area and perimeter, it is important to include units. So remember, area is always square units and perimeter is just regular units. So in section 8, we talked about volume and surface area. So you are allowed to use that volume and surface area formula sheet on your test. I would make sure you have that handy. So just to review, for cone, the volume of a cone is 1 1/3 pi r squared h, and its surface area is pi r squared plus pi r L. Okay. So we want to find the volume and the surface area. So our volume, we're going to do 1/3 pi, and then our radius 8 squared times our height 18. So 1/3 times pi, and then 8 squared is 64 times 18, and it's going to give us 1,206.37 centimeters cubed. Remember, volume is cubic units. Now, in order to find the surface area of a cone, I have to know the slant height, L. So to solve for the slant height, I'm first going to use the Pythagorean theorem. So 8 squared plus 18 squared equals L squared. So 64 plus, and then 18 squared is 324. So we get 388 equals L squared. Take the square root. We have a slant height of 19.7. So now I can find the surface area. Pi times the radius 8 squared plus pi times the radius 8 times our slant height 19.7. So we have pi times 64 plus pi times 8 times 19.7, and we're going to get 696.18 centimeters squared. Because remember, surface area is square units. So next we want to find the volume and surface area of a sphere. So from our notes, volume is 4/3 pi r cubed, and surface area is 4 pi r squared. So we want to find the volume and the surface area. So for volume, we're going to do 4/3 pi times the radius 30 cubed. So 30 cubed is 27,000. So we're going to do 4/3 times pi times 27,000. And we're going to get 113,097.34 meters cubed. And for our surface area, we're going to do 4 pi times the radius 30 squared. So 30 squared is 900. So we're going to do 4 times pi times 900. And we're going to get 11,309.73 meters squared. So the last section talked about volume and surface area of composite solids. So it's taking two solids and combining them to find their volume and surface area. So in our figure, we have a cylinder and a cone. So from our formula sheet, the cone has a volume of 1/3 pi r squared h, and the surface area is pi r squared plus pi r L. Cylinder has a volume of pi r squared h and a surface area of 2 pi r h plus 2 pi r squared. Okay. So the nice thing about volume for composite solids, you just find the volume of each solid and add them together. That one's pretty straightforward. It's the surface area that gets tricky. So the volume of the cone is going to be 1/3 pi, then the radius of our circle, 5 squared, and then the height of the cone, we are not actually given. So we're actually given the slant height is 13. So first I want to solve for the height of the cone. We're going to do h squared plus 5 squared equals 13 squared. So we get h squared plus 25 equals 169. Subtract 25 and we get h squared equals 144. Take the square root and our height is 12. This is the cone. So we do 1/3 times pi, 5 squared is 25, times 12, and we get 314.16 centimeters cubed. Now we want to find the volume of our cylinder. So pi times the radius is still 5, and then the height of the cylinder is 2. So pi times 25 times 2. It's going to give us 157.1 centimeters cubed. So our total volume, 314.16 plus 157.1, is going to be 471.26 centimeters cubed. So volume is the easy one. Surface area is where it gets tricky, because with surface area, you only care about the area on the outside, not the inside. And when we're dealing with two separate shapes, that's fine, because you just use their formula. But in this case, they both have one circular base that is the shared one. So it's technically inside our composite solid. So we don't want to include it in the total surface area of our figure. So for the surface area of our cone, that means not including the pi r squared, since that accounts for the area of the circular base. So we just want to use pi rl. So pi times 5 times 13. So pi times 5 times 13, which is going to give us 204.2 centimeters squared. For our cylinder, we have 2 pi rh plus 2 pi r squared. So instead of that 2 pi r squared, which is both circular bases, we're only going to do one of our pi r squareds. So we're going to do pi times the radius 5 times the height 2 plus pi times 5 squared. So pi times 10 plus pi times 25. And we're going to get 109.96 centimeters squared. So our total surface area is going to be 204.2 plus 109.96, which is 314.16 centimeters squared. So it's extremely important for the composite solids that you are paying attention to what part of the figure is inside for surface area to not include. And then for volume, just add your two volumes together. Let me know if there's any questions you still have over anything from Module 3 before you take your test.